We're going to go through an example here to calculate relative humidity. Relative humidity is equal to the specific humidity of the atmosphere divided by the absolute humidity, which is a function of the temperature of the atmosphere, multiplied by 100. And relative humidity is expressed as a percent. So it's really the ratio of moisture in the atmosphere to the amount of moisture that the atmosphere could hold at a specific temperature. Let's go through an example here of how one might actually calculate relative humidity. And we'll do this for both morning and night. So the example that we'll give is that let's assume you wake up in the morning and you see frost outside. The occurrence of frost or condensation assumes that at some point we had 100% humidity, we had saturation going on. And let's just say for the case here that we had a temperature of 0 degrees Celsius, and at that time we also had condensation occurring. So at night, let's just say this is actually at 6 a.m., what we would find is that we had a temperature equal to 0 degrees Celsius, and we also had a dew point temperature, which I'll abbreviate here as TD, equal to 0 degrees Celsius. Okay, and we know at this point we have a saturated atmosphere, and it turns out that we can write our equation here for relative humidity as 100% times the specific humidity of the atmosphere divided by the absolute humidity of the atmosphere. Typically, we don't necessarily see on the weather report observations of specific humidity or absolute humidity, but these can be measured. And it turns out that at a temperature of 0 degrees Celsius, we have a specific humidity of the atmosphere of around 3.8 grams per kilogram. Okay, and since we also know that the air is saturated at this point, our absolute humidity is also equal to 3.8 grams per kilogram. Okay, and this gives us that relative humidity of 100%. The second example is we're going to consider what happens during the daytime hours. And in the daytime hours, let's assume here we're going to go forward to 3 p.m. And we're going to assume that the dew point temperature did not change from the morning hours. So the dew point temperature is still 0 degrees Celsius, but the afternoon high temperature is 20 degrees Celsius. So how are we going to calculate relative humidity? What we don't want to do is we do not want to try to calculate relative humidity by dividing the dew point by the temperature. And what you can clearly see, if you try to do that here, you'd get a relative humidity of 0%. If you tried changing the units to a different measurement of temperature, you'd get a different number. So that's not the appropriate way to do things. What we need to do is we need to write our equation for relative humidity, just like we did before. We know that the specific humidity of the atmosphere is still what it was in the morning, so that's still 3.8 grams per kilogram. And the absolute humidity now, once we move into the afternoon hours, the air warms up, and as the air warms up, it can hold appreciably more water vapor. And it turns out that the absolute humidity for a temperature of 20 degrees Celsius is around 14.6 grams per kilogram. So we could go through and we could take our calculator out, and what we'd find is that when we did this, we end up with a relative humidity in the afternoon hours of around 26%. And typically what we'll find is that the maximum relative humidity during a typical day without any precipitation occurs at sunrise when temperatures are the lowest, and the lowest relative humidity during a day typically occurs in the afternoon hours when the maximum temperature occurs.